If you are working on data science projects for some time now, then you must have encountered a problem known as imbalanced data problem or imbalanced class problem. Let me ask you this, guys. What is the typical approach that you take to tackle imbalanced class? How do you handle that problem? Are there some methods which you always use to handle this, or do you do some research on that? Do you think that there should be more number of methods, more number of offerings to use from while working with imbalanced data? Do you think that the approach can be slightly different apart from using the inbuilt Python functions so that we can get more meaning out of the data? If your answer is yes, this video is for you. Welcome to Unfold Data Science. My name is Aman and I am a data scientist. In this video, I am going to show you the 5 ways in which you can approach the imbalanced class problem. I am talking about 5 ways, guys, not 5 methods or 5 Python functions. 5 ways in which you can approach the problem. In all these ways, I am going to show you different methods through which you can approach the problem. I am also going to show you some of the methods which is specific for deep learning modules and how these can be used. I am going to show you the Python demo of all these and show you the theory behind all these as well. So let's go ahead to my screen, guys, and I am going to show you all these one by one. Okay. So guys, first of all, we will try to understand what is the meaning of a imbalanced class scenario with this simple example. Okay. So I have a credit card data here. You can have transaction time, you can have transaction amount, and you can have is fraud. Is fraud is your target column in this case. Okay. That is what you have to predict. So I have transaction time, for example, 10 a.m., 8 a.m., 7 a.m. I have transaction volume like 20, 21, 30, 13,500, right? Now look at this column carefully, guys, your target column. How many no values you have? 4 no values, okay? And how many yes values you have? Only one yes value. So if I ask you what is the ratio of no and yes in your target column, so no becomes your 80% because 4 out of 5, and yes becomes your 20% because 1 out of 5, right? So this kind of scenario is called a imbalanced class problem, and this is a problem. Why? Because your model may get biased towards the majority class. What is the majority class here? No class. The thing to understand here is we are more interested in knowing the pattern of fraud transactions, which means these Y transactions we are more interested in understanding. But since we don't have sufficient sample, model may not be able to learn the pattern of this class at all. This is a very, very common problem in the industry. Okay. Here I am talking about 80-20. You will have the ratio like 90-10, sometimes 95-5, and sometimes I have seen 99% and 1% ratio also. All these are examples of your imbalanced data. If you train your model with this original data, your model will be biased and maybe it will not be of much use in real world. How to tackle this problem? That is what this video is all about. So guys, there are 4 ways you can approach this, imbalanced class problem, or 4 routes you can take. Here I'm going to talk about 5 routes basically. Okay, so let me write here one by one what I'm talking here. One is called undersampling. Okay, undersampling. Undersampling means by doing something, I will talk about what is that something. By doing something, you will bring this 80% down. Okay, probably you will bring this 80% close to 20%, which means out of these 4 samples, you will take only 1 sample in model training. Okay, this is not as straightforward as I am telling. I will tell you what are the methods. Okay, this is called undersampling minority class. There are positives and negatives with all the approaches. I'll talk about that. Second approach is called oversampling. Okay, oversampling the minority class. So I will use this word again and again, guys. When I'm saying minority class means something which is less. When I'm using majority class means something which is more. Okay, so oversampling minority class. So this 20%, can I make this 20% as 80% by doing something? Okay, I will talk about the methods, but this is way too. Okay, now one thing to understand here, guys, the ideal situation is to have a 50-50% ratio. What is the ideal situation? 50% no, 50% yes. We are aiming for that. Okay, so this is about your oversampling. Then a combination of undersampling and oversampling. The third way, okay, combo of undersampling plus oversampling. Okay, this is the third way. What is the fourth way? The fourth way is basically ensemble approach. Okay, so this is basically modeling approach that we will take, and fifth approach is basically batch approach, batch selection for model training. This fifth one is applicable for your TensorFlow and Keras models when you are training deep learning models. Ensembles will use your ensemble models like random forest, AdaBoost, etc. And these things I will show you what are different techniques. Okay, so let me go to the Python and show you guys one notebook here. Let me go to this notebook. Okay, how to work with imbalanced data. I have taken a small data here, German credit data. This is known as, so this is basically again a financial system data. Okay, and here you have data frame.head I'm doing. So this credibility column, right? Credibility column is the column which is our target variable. So if credibility is 1, then the customer is good customer. 0 means customer is not a good customer. Okay, and then you have account balance, then you have duration of credit, then you have payment status, purpose, credit amount, many things you have here in your data. So I'm not bothered about many things, occupation, number of dependents, telephone, many things, right? I just want to see how the target variable is distributed, which means what is their percentage distribution. So I go ahead and see their count. So data frame credibility value counts. Now you can see here, guys, this is 700 and 300, which means 70-30 ratio. Now I give you example of 80-20 ratio. Here I have 70-30 ratio. If I want to plot it, I will be seeing a chart like this. Okay, count plot SNS. So one class means reliable customer or credible customer are 70%, but non-reliable customers are 30%. Now I want to understand the pattern. What makes a customer non-reliable in my model training, right? So what I have to do first, I told you in ideal world, the ideal scenario will be 50-50% distribution. Okay, so let's see some of the approaches that I discussed here. What is the first thing I discussed? Undersampling. Let's go ahead and try to do undersampling first. What is the first method I'm using in undersampling, guys? So I'm importing a package called IMBlearn. I'm importing a from collection module, I'm importing counter. I'm separating my target variable and independent variables. Okay, I'm just plotting here original distribution of the target column. Okay, so let me run this from here. Let me run this. Let me run this again. So you will see that I'm plotting on two, X and Y. Duration of credit is one column and credit amount is another column. These two columns come from the data itself. Okay, don't bother about these two columns. Just something I have to keep on X-axis and Y-axis, so I keep it. And then you will see a plot like this. This plot tells you, this orange dot tells you all the zeros, and this blue dot tells you all the ones. So obviously orange dots will be less in number, right? Because zeros are less. If you see here, zeros are less. So orange dots will be less in number. This is your actual distribution, means actual data. Okay. Now for the benefit of all of you and for comparing it, I have saved it as a PNG here. So this is the same PNG. What I will do, whatever technique I will apply, right, I will compare with this original thing. Okay, so this is a photo. I will come to this photo, I'll compare and show you what I'm doing. Okay, this is the same photo which I have plotted here. Fine. Now what is the first technique, guys, in undersampling? The very first and common technique that we use in undersampling is called random undersampling. Random undersampling. So let me write here, this is called random method. What we do in random method is, out of this 80% data, we will randomly take 20% out. Not 20%, we will make it similar to this 20%. So out of these 4 observations, I want only 1 observation. Why? Because I want to reach to 20% of the population. Okay, suppose here we have 4 records and here we have 1 record. I will just go ahead and choose 1 record at random from these 4 records. That is your random undersampling. Randomly, no fundamental behind that, no mathematics behind that. Randomly I am choosing 1 record. Okay, so that is called your random undersampling. How to do that? We have to go here and we have to, from IMBlearn.undersampling, I'm importing random undersampler. You see here, random undersampler I'm importing. I'm fit sample on original data. So X resample and Y resample become my new data after resampling. and then I'm plotting it to compare with my original plot and see how many observations are left. So you see here, after undersample, data shape 0 is 300 and 1 is 300, which means previously 1 was 700. Remember guys, see here, previously 1 was 700, now it became 300. So this is a randomly selected 300 observations. So this is your new chart. Okay, now if you come here and compare your new chart with the image I have saved, right? This is the original data. Now compare this guys, this looks more dense, right? And this looks less dense, which means some of the orange data points have been deleted. Remember this guys, orange data points, which means majority class. You see here, orange data density is here where I'm hovering my cursor. This is 50. You see below 50, I'm hovering my cursor. Come here, below 50, gone. Okay. So from all over the places, right, you will see the orange data concentration is, reduced, which means randomly 300 records have been selected. Very simple to understand. This is done. But this is a very naive approach. This is very simple approach. No, it doesn't give lot of benefit, and we are kind of not drawing any meaning from the data. We are losing some information from the data. So not a very good approach always. The second approach is called a centroid based approach. Now what happens in centroid based approach is, suppose in your data there are some majority and minority class. So let's say these are your majority classes, okay, and these are your minority class. Fine. Now let's say I have to find 4 data points from the majority class. So what will happen is 4 clusters will be created here. Call it cluster 1, call it cluster 2, call it cluster 3, and call it cluster 4 in majority class. Okay. How many data points I want to choose from majority? 4. So how many clusters I'm creating? 4. I will take centroid of all these clusters. You can think of it as k-means cluster, taking the centroid. So my target was to get 4 from the majority class. This way I will get 4. Let me show you that in Python. You come here and you say import cluster centroids. Rest of the methods remain same. Okay. And then you run this. If you run this guys, then the difference, you will not see much difference from the previous one, because previous one was random, but this looks little more meaningful, right? Because you only think from your common sense, right? Cluster centers will be created only at the point where there is more concentration, right? So little more it's making sense. Okay. So if we compare with the original one, right, this one, then you will see that data points have been reduced, but this is not randomly reduced. This is not randomly reduced. This is reduced in cluster centroid method. Okay. Now these two methods that we discussed now, guys, these two methods are known as selection based method. Okay. Selection based methods, because we are selecting some data point from the majority class. There is something called as deletion based approach. We will delete something from the majority class. Okay. Let's see how. Now, suppose there is an approach in undersampling that is known as ENN, or edited nearest neighbors. Okay, edited nearest neighbor. Let me tell you what is that. So let's draw some data points here, guys, from any class, from majority, minority, any class. Okay, and let's say one data point at random is chosen. For example, this data point. Okay, this X data point. Now let's see 5 neighbors of this data point. Neighbor 1, neighbor 2, neighbor 3, neighbor 4, neighbor 5. So what is the mode of those 5 neighbors? Mode means either they fall to 0 category or 1 category. Okay. So mode of neighbors. If that mode matches with the category of this chosen sample, then keep all the sample, otherwise delete all the samples. Okay, so this is a deletion based approach. You will delete some samples. Okay, now if I come here in my Python, right, then you will see that some of the data points will get deleted. It is not a selection method. Okay, so let me run here and you will see that ideally it should be 300 and 300 this and 300 this, but here it is becoming 271 this. Why? Because in some iteration more of class 1 have been deleted, more values of class 1 have been deleted. Okay, so this will also be a kind of undersampled approach, but a different approach. Now I have spoken about just 3 approaches, guys, but you need to study about some of the important ones. One is KNN based, other is called as near miss, and third is called as Tomek links. You must study about these. Okay, these are also some of the undersampling approaches. Okay, now let's move on to the approach 2 for dealing with imbalanced data, that is oversampling. In oversampling, what we do? So in oversampling, basically, you see this 20% of records, right? By doing something, can I make this similar to this number? So this is one record, right? If I duplicate this one record 4 times, right? 4 times same record, then it will become 4, and no records were also 4. This is your random oversampling. Okay, random oversampling means duplicating the same records many times. So let me go ahead in Python, run this random oversampler. The approach is same, hence I'm not walking you through the code all the time. Random oversampler, run this. Now you will see that both 0, see before original data counter 1 700 0 300, after 1 700 and 0 also 700. So records have been duplicated. Okay, if you compare with the original chart, you will not find any difference. You will not observe any difference, guys. Can you tell me what is the reason for that? The reason for that is the dots are plotted on top of each other. Okay, because that's a duplicate record, right? So you won't be able to observe any difference between this chart and this chart. Okay, because this is just a duplication. But this is not again a good approach, because you are duplicating the data, and your data will have some bias. You are unnecessarily giving the same information to the model again. Okay, what is the other approach? Oversampling second approach is known as SMOT. SMOT stands for synthetic minority oversampling technique. Here you don't duplicate the records, rather you create new records. How? Let me tell you. This is an oversampling technique of minority class. Remember, minority class means that 20% we will try to raise up. Okay, so suppose here I have first data point, second data point, third data point, fourth data point, fifth data point, all are minority sample I'm talking about. Okay, let's say this is one data point. Okay, how many neighbors it has? Nearest neighbor 1, 2, 3 neighbors. So using these 3 neighbors, right, one new synthetic data will be generated. Synthetic data, not the real data. For simplicity, if I have to generate a data between this and this, then a new data point will be generated here. To keep it very simple, I will give you a simple example. Let's say in this data point, the value is age and salary. This data point value is, let's say, 20, salary is, let's say, 11. Here, this data point age is, let's say, 25, and salary is, let's say, 8. Okay, just an example I'm giving, don't take it literally. So if I have to generate a new data set here, then maybe I will take an average of these two. Just an example I'm giving. So new data point, this data point will be 20 plus 25 by 2, 11 plus 8 by 2. Now there is a mathematics inside it. There is a vector quantity that is being multiplied with this. Okay, and then the synthetic data is generated. But this is a synthetic data that is generated, not the real data. What are the pluses and minuses of this approach, guys? This approach, you are not taking your original data, duplicating your original data, hence little better than random oversampling. But again, since you are creating from the main data, so little bias gets introduced. Now compare this with your original. You will see how the data is being generated. See this, guys. So here you don't see orange dots. Now this is your PNG. PNG means original data. No orange dots. Here orange dots, which means new data have been generated. New data, synthetic data, not the original data. Okay, this is about your SMOT. Synthetic data generation, you need to learn about many varieties of SMOT, which I cannot cover in this video because it will be very, very long. Then it will be SMOT-NC, SMOT-N, borderline SMOT, K-means SMOT, SVM SMOT, and ADA-SYN. Okay, I will show you where to learn all these in a moment. Just give me a few moments. Okay, and then you can have mix of undersampling and oversampling, that is known as, one example I'm giving here, SMOT ENN. So I explained you ENN, I explained you SMOT. This is a combination. From one side it will be undersampled, other side it will be oversampled. Let's see how. So if I run this SMOT ENN, right, then you will see that the data point count, right, see here, originally 700 300 ratio, now 0 becomes 307 and 1 becomes 209. So from both the sides it's working. From one side SMOT is working, other side ENN is working. And if you want to compare this with your original data, right, so you see this and you come here to your PNG, right? You will see that it looks little different than PNG because both the things are working. Smart and EN and both are working. Okay. You have to learn about one more technique in this known as smooth to make. To make is nothing but one approach in undersampling that I have listed also here. Let me show you. See, Tomic links, right? This one combination with smooth you have to learn because this is important. Okay. Mix of undersampling and oversampling. Now you have to learn about ensemble method. Ensemble method is the fourth approach that I have listed here. Okay, fourth approach that I have listed here. Ensemble. So in ensemble, what will happen is multiple models will get created and all the models will get created on a balanced data. Balanced data will be chosen. Random undersampling from your data. Okay, random undersampler will choose random undersampling, create a bag, fit a model, create a bag, fit another model. So this is called easy ensemble classifier. One example of that. I am fitting a model and results does not look that bad. Okay, easy ensemble classifier. This is model fitting, not the data creation. Remember, you have to use the model itself directly here. Okay, and other methods where to learn and how to learn about that I'm going to show you in the IMB learn page because I'm using all the things from there, guys. Let me go ahead here. So in undersampling method, I told you centroid cluster, I explained you. Edited nearest neighbor, I explained you. See how many methods are there: near maze, condensed neighbor, many things. One-sided selection, Tomic links, you need to understand. Then oversampling methods, smooth, all the varieties. Combination, easy sampler, I showed you. Here, smooth NN, I showed you. Smooth to make, you have to understand. Easy ensemble classifier, I showed you. Random forest classifier is there. Bagging classifier is there. Boost classifier is there. You have to understand this. Batch generator for Keras, what it will do? Important. This is for your deep learning models. Created balanced batches when training a Keras model. When you want to train a Keras model, you want to see data in batches. That data will automatically be created in a balanced way. There you use your balanced batch generator. Okay, balance generator for TensorFlow is also there. You can use imblearn.tensorflow.balance batch generator. For Keras, you can use for Keras specific thing. Okay, imblearn.keras.balanced batch generator. But remember, guys, none of these techniques is a sure shot guarantee that your model will do good, right? Understand this, guys. This is a centroid based thing, right? So in which approach centroid will work fine, we don't know. Depends on the data distribution. But in the war, if you have more weapons in your hand, right, then you can use more weapons. I'm sure you learned something new in this video, right? You can combine undersampling and oversampling. You can do ensemble and many things. So I will upload this notebook in my Jupyter, in my Google Drive, guys. Let me know if you have any doubts. I'll see you all in the next video. Give me a thumbs up if you like this video. Wherever you are, guys, till then, stay safe and take care.